Okay, so let's say you've just taken some data with the DRS4 and you saved it as cosmictest.xml. Okay, so that's a .xml file. You can run the DRS4Analyzer on that. DRS4Analyzer on one or as many files as you want. If I had cosmictest1.xml, cosmictest2.xml, I could do star here and import all of them in order to create a single n tuple with all of them in there. I only have the one, so let's run it on the single file. So what this does, it runs the program. It says, I've loaded this into memory. Should I create the n tuple? If you say no to this, the program ends. You can't do anything further. So let's say 1. Let's do it. So it's processing event 0 every 1,000 or every 500 events. It'll tell you where it's at. So it just finished processing 162 events. So now it's asking me, do I want to save the PMT gains? So if I took data with a PMT, this is necessary to calculate the photoelectrons in the second part of the analysis. So I'm going to say yes to this because we did use a PMT. So let's say it's an R7525 or whatever specific serial of the PMT. Put that in here. You want the gain on the channel. So let's say it's 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5. 1 times 10 to the 5th. R7525, 6. R7525, or you could do 1E5. R7525, 1, 2, 4, 5, 6. So this automatically determines how many channels there are in the DRS4 that were enabled in taking data. If your XML only has channel 1 in it, you're only going to be asked channel 1. You won't have to put in all 4 channels. So now it tells me that n tuple 1 has successfully been created, and now it moves on to step 2. So this happens if you just run the program without inputting any XML file. It looks for the step 1 n tuples.root. If it finds it, it goes here. Inside that root file, it found this tree, PMTs, which has the PMT gain and serial numbers, and this tree, n tuple 1. And then the original root, input file was cosmictest.xml. So if you had 2 files that you n-tupleized, you'd have cosmictest1.xml, and then underneath it, it would find cosmictest2.xml, and that would be called n tuple 2, which would have wavelength and amplitude for each channel in that n tuple. So now we have an option. We can open the T browser at this point to take a look, see what we get. Inside the T browser, we have PMTs, which has the gains and serial tree here, and the n tuple. So we've got the amplitudes for channel 1, 2, 3, 4. So this is our pedestal value over here. So I'm going to close this, and it gave me an error there. It said it could not find step 2, which is fine. We have to create that. So now let's analyze the file, analyze the waveform. So I enter number 1 to do that. So it's asking me how many waveforms do I want to plot. Let's say we took 50,000 events. We don't want to see 50,000 waveforms. We want to see the most interesting. Let's say the most interesting 10. So I put 10 here. I want to plot 10 waveforms. What threshold for plotting the waveforms do I want to put in? Well, let's say I want to see the 10 waveforms. The first 10 waveforms I have a threshold above, let's say 20 millivolts. It depends on your signal, right? Okay, so now it's processing each channel. Now it says finished fitting, finished processing pedestals, finished processing waveforms, finished processing fitting waveforms. So what it does here, let's open the T browser right now. What it did, analyzed that step 1 file and created a folder with these waveforms. So it plots a waveform for each channel. Channel 1, 2, 3, first one, second one, third one, fourth one, fifth one for each channel. Okay, so we can see channel 4 is the only one really having anything useful in it. Actually, I'm not sure what these first ones are. But anyway, so these are our real cosmic signals. What it tells you, each of these waveforms, tells you the peak, where the peak happened. So the peak happened here at 75 nanoseconds, 76 nanoseconds. It took from the peak to half of the waveform, it took 1.56 nanoseconds. From peak to 1 over E, it took 3.7 nanoseconds. Peak to 1 over 10, it took 120 nanoseconds. So 1 over 10 is going to be somewhere out here or even here. So these calculations just use find last bin above whatever value, 1 over 10 of the peak, 1 over 10 of the max value, for example. Okay, so that's the first part of the analysis, just to create waveforms. Second part of the analysis is it puts the amplitudes of each of these channels in here. It fits the amplitudes. As you can see, channel 1 had nothing. Now it subtracts the pedestal from that. So you can see when you subtract the pedestal, you're left with a very small signal here. It calculates the integral of each signal, and there's not very much going on here, and then tries to calculate the PEs from those signals. And then it saves the peaks, where the peaks happen. So let's go to channel 4, which had some good data. So here's channel 4. Here's the amplitude. There's your pedestal value. Here's some real signals. So after you subtract the pedestal and suppress the zeros, negative 0 numbers, you get here for your signals. Here's the integral of those signals, somewhere here in femtocoulombs. Calculate the PEs from there. So remember, I made up the number here for the gain of the PMT, but it's saying that on average, 12 photoelectrons here. And if you look at the peaks, then what's telling you is where the peak was. It's saving the peak value, the time slice at the amplitude. 20 nanoseconds, 40 nanoseconds, 16. So there's one event where the peak was at 25 nanoseconds, 30 nanoseconds, one where it was 50, 60, 100. So the reason I created this, there's two fit functions here. You can notice over here it says warning fit data is empty, so the second fit didn't work. That test beam we took data and we were getting two distinct arrive times, one about 60 nanoseconds, one about 100 nanoseconds. And so I was trying to show that there were two different phenomena going on that we needed to understand. So you can go in the code and change this to figure out where that is. But that's how it works. So now if you quit here and just run DRS4Analyzer, if you've already created this n-tuple file, you can just run DRS4 and then press 1 to analyze it again. So this is really useful if you've created, if you changed the code, you want to change the analysis, add some histograms or something, and then remake the program with make, then you can just do that without having to recreate the n-tuple. So it's pretty nice and works that way. So I guess that's it. Let me know if you have any questions.